Welcome to this screencast. We are looking at functions of a CPU for GCSE computer science. Now at GCSE level, and this is the revision guide that you've all got, well, all my students in my lesson, there are three main parts of a CPU that you must know for your exam. You're familiar with the cache, you've done loads of questions about the cache. Most of you are familiar with the arithmetic logic unit that does all the calculation, logical or mathematic, inside the CPU. The control unit is the third and last key part of the CPU at GCSE level, and it's in charge of managing all what happens inside the CPU. When we put this together with this diagram here, so the control unit will have one register, the program counter, which is abbreviated as PC, and that stores the next instruction to be fetched from a memory in the FDE cycle. The ALU has got, in this model, the accumulator register that's going to temporarily store the result of a calculation or one of the two values to be operated on to a calculation with. Then you've got two key registers, and the exam board OCR really likes to ask questions where students might confuse the two. So memory address register only holds an address to access the memory, and the memory data register can contain data either to write to the memory, or when it's a read operation, you set the address you want to read from on the memory address register. The control unit will notify the memory that it's a read operation, and the memory will put the content of that one address, and that's going to be loaded in the memory data register. If we move on to the fetch, decode, execute cycle, which is very important at GCSE level, so there's a couple of corrections here I would like to do to annotate. Copy the memory address from a program counter to the memory address register. So the program counter, so that's the next instruction in the FDE cycle. Now, so from the program counter, it goes to the memory address register in order to fetch these next instructions from the memory. The control unit will know that at this instant, what you're getting from a memory is not data, it's the next instruction. But whatever you get from a memory will be on the memory data register. So the memory data register at that moment will be sent to the control unit, because the control unit is in charge of decoding. There's one thing here, I found that sentence a little bit misleading. Copy the instruction stored in memory to the MDR. So the instruction is stored in the memory. You got to fetch it from the memory, send it to the CPU, and when you retrieve something from the memory, it goes in the MDR. Now we have got hold of our next instruction, and because we know we're in the fetch cycle, that's then going to move to the control unit, ready to decode it. Now the decoding, that's the job of a control unit here to do that. Once you've decoded the instruction, the CPU is ready to execute it. Now, executing the instruction, that can be either doing a calculation, and that's when the ALU comes in, or it could be to interact with some input device or interact with a memory. For example, if you are at the end of a piece of code you've written and you got to store a final score in a game, then that instruction will be all done by the control unit, and it's a question of interfacing with the memory. Now, today we've done some exercise to do with this, and I would like to use this screencast to review some of the questions there. So here we've got a question, typical, this is from OCR themselves. Explain how the cache size affects the performance of the CPU. Now, something that's critical here, and I'm going to highlight it, is the use of the word to access. So OCR will want to read in your answer that you're accessing the RAM. So the cache is faster to access rather than the RAM. If you don't use the word access, you risk not getting the point. And as this was a 2-mark question, so this will, if it's a 2-mark, then let's say you do almost a P paragraph. So this here is your point. And to score the 2nd mark, you're going to explain it. So increasing the cache improves the CPU performance to secure that 2nd mark. Some of the other questions we did today, we had here something that caused some confusion. So here we got some CPU instructions in binary in machine language. And there's some meaning to the instructions. So we got 2 add operation, and then the next 2, it's add 1 to the timer and 1 to the timer. And here we are asked to explain what is an opcode, what is an operand. So all these instructions, you can split them in half. Part of the instruction is the opcode, which specify which instruction is going to happen next. And there we've got add to the timer. So we've got these in common. So what we can spot is that those are identical. And that's the only thing that's identical between the 1st and the 2nd instruction. So this here is our opcode. And to secure the 2nd mark, we can then give an example in this case. So let's take this one, add to the timer. Why this one? Because we got it twice. So I would use that one. The operand is the data or the address that the computer is going to need in order to carry out this instruction. So here we've got 20. And if you got time to do the calculation, no 1, no 2, a 4, and a 16, that makes the value 20 in binary. And there, 1, which we again have got twice. So in this case, you got loads of help in the wording of the question itself in order to help you answer this. And again, because it's a 2-mark question, so we've got 1 point here, and then we give an example to secure the 2nd mark. One last thing I would like to discuss in this screencast is this question there. Explain how the CPU can determine whether it represents an instruction or data. Now this is the job of a control unit. The control unit will know at which stage we are in the fetch, decode, execute cycle. Because how the CPU interacts with the memory is always the same. The CPU will put an address in the MAR, will notify the memory that we want to read from this address. And sorry, there's going to be a 3rd bell after this. So I was saying that the CPU, the control unit, will know where we are in the fetch, decode, execute cycle. And if we're in the fetch part of the cycle, then whatever we're going to get from the memory via the MDR is an instruction. So possible answer would be the control unit dictates whether the memory is accessed to fetch an instruction or to execute an operation. Now there's only 1 mark here. If it was a 3-mark question, I would add depending where we are in the fetch in the FD cycle. Thank you for listening to this screencast, and we're going to practice a bit more of this in our next lesson.